Hi there. Today we're going to talk about the hypergeometric distribution in 5 minutes. To make it clear, let's start with an example and then discuss the general case. Let's say that we have 20 balls altogether, of which 13 are green, 5 are blue, and 2 are red. Now we randomly pick 4 balls without replacement. What's the chance that we have exactly 3 green balls? So we have a special set of green balls, of which we pick exactly 3, and the second set of blue and red balls, and therefore we pick only 1. Since the total we pick 4 balls, we can pick only the one that's left. Now this is how it's calculated. The probability for 3 green balls would be 13 choose 3 times 7 choose 1 over 20 choose 4. Altogether, this is 41.32%. Now let's say that we pick 5 balls with no replacement. What's the chance that at least 1 ball is red? So we have only 2 balls, only 2 red balls, right, and 18 non-red balls. So what we're looking for the probability for red to be more than 1 or more than 1, which is 1 minus the probability for 0 red balls pulled. So altogether, this would be 1 minus 18 choose 5. 18 would be the non-red balls, times 2 choose 0, which are 0 balls picked from the 2 red balls. Altogether, over 20 choose 5. Altogether, we have 44.74%. Now, the hypergeometric distribution, we have 2 sets of elements that sums up to n elements in total. One set is considered special and has k elements, while k is going from 0 to n. And the other is consisted of all the rest, which is capital N minus k elements. Now we randomly pick without replacement capital D elements, and capital D goes from 1 to small n. And we're looking for a probability to find exactly small d elements, while small d is going from 1 to capital D. Now this is the way to find the probability. If we're looking for the probability to find exactly small d elements, we're looking for the probability. The calculation would be small k choose d times n minus small k choose capital D minus d over n choose capital D. Now the expected value for the hypergeometric function distribution would be d times k over capital N. The variance would be this long expression, and the standard deviation would be, of course, the square root of the variance, which is this very long expression. Thank you for listening. I hope this was helpful for you. Have a good day and see you in the next session.